Hi, today we're going to be doing a fairly simple Xcode application in Objective-C. Tried this review out earlier and it went over very long, so trying it again, but trying to keep it short and simple. Opening up Xcode right now, and so here is Xcode as it will shortly open up, hopefully. Okay, so I'm going to create a new Xcode project, and I'm going to select macOS 10 application, global application, make sure these are unchecked, and click choose. I'm just going to name this, as you see there, it's going to be a fraction. That's my old project that I said took so long. Let's just name it test application this time. So anyway, I'm greeted with the very familiar Xcode interface, and I'm going to go into classes and right click add new file, and I'm going to create a Cocoa Objective-C class. Click next. Make sure that's a subclass of NS object. Next. And then I'm going to name it fraction.m. Okay. And also create fraction.h, finish. Alright. So I have these two, and the only other thing I'm going to change is very quickly go into the main, do two things. Make this constant, const, and get rid of this and make it 0. Well, before I do that, I'll explain that when it returns this NS application main, it's going to give back that very familiar application. So if I bring up save all, it'll bring up this standard template for an application in a moment here. So it'll bring up this with the title bar, its menus, etc. But I don't need that for this application, so I'm just going to type 0. So don't worry about constant, but yeah. So do that, save it, and go to fraction.h. Now fraction.h is the header file of the fraction class. Okay, now the header file deals with all of the setup. So all of the declarations for things in the fraction class. Now, it's important to remember that when we deal with classes, we're not dealing with specific instances. And instance is a word that you'll hear very often, but if you think about it like this, if you think of the concept dog, dog is comparable to a class in that your dog, your specific dog, of whatever breed with certain name, the certain personality that it has, is an instance of a dog. It is a particular dog. So in a fraction, therefore, a fraction can be any fraction whatsoever. A fraction has a numerator and a denominator, but if I say 3/4, 3/4 is a very specific fraction with the numerator of 3 and the denominator of 4. So 3/4 is analogous to your specific dog, and fraction, the class object, is analogous to dogs in general. Okay, so that's why we can't, we won't be hard coding some of this, and you'll understand later. So the first thing is between the @interface brackets here, I'm going to declare all of my instance variables. And these are variables that are going to be declared for every instance. So for each instance, these variables are going to hold different values. Okay, so first of all, I need an integer of that I'm going to call numerator. And the second one, I'm also going to need an integer that I'm going to call denominator. Just going to delete that space. And so there we go. Instance variables, like I said, fraction has a numerator and a denominator, but a specific fraction has to hold a specific one. And for the fraction that's 3/4, obviously numerator and denominator are different than the fraction that's, say, 5/7. So now, going on, after this bracket and before this add end, we're going to add all of our instance methods. Now, for methods, there are two typical characters that start a method. The first is a minus, the second is a plus. Now, plus refers to class methods, meaning that they're specific to the class and not instances. Don't worry about that in this case because we're going to be using instance methods because all of these methods are specific to the instance itself, the same as the integer numerator and integer denominator. Okay, so the return type, what we're giving back in this method is an integer, and this method is going to be called numerator. And so just from this syntax, what I know is that this method I'm declaring is supposed to just give back the numerator, and likewise this one will give back the denominator. Secondly, we would probably like a method that allows us to change these. So we're not giving anything back, we're just doing a command. So the return type is invalid. Another word to say invalid is quote unquote null and void, if you've ever heard that expression. And so that is the reason that this return type is void. And I'm going to call it set numerator. But if you think about it, you need to tell the application or the person using this method needs to tell the program what to set the numerator to. Now again, we're writing this not for a particular instance, but on this very general basis. So we need to know what the integer is, but let's say if we say 7, then the numerator is always going to be equal to 7 if it does what it's supposed to, if this method does what it's supposed to. So what we're going to do instead is make a variable for this. I'm going to call it n, but we need to know what type it is, and so it's going to be int, an integer. And so this, I'm just going to call it n because it stands for numerator and it makes sense to me. But likewise, we're going to do the same for set denominator. And I'm going to call it int d. And I mean, I could have called this p or o or I or u, but I'd rather have it as d because it makes more sense that it would correspond to the variable that it's going to be changing. And the last thing I'm going to do is just make a void for fun that will simply do the command of printing this fraction out. Okay. Now remember that the semicolon ends the statements, all right? And so these statements are just stating that we have these methods available. Okay, so I'm going to copy these, Command C, copy, and I'm going to come over to the .m file, which is the implementation file, and paste it in between add implementation and add n. Okay, now for each one of these, and just because I'm lazy, but for each one of these I'm going to delete the semicolon, give myself some space, and put the open curly braces, and it automatically inserts the closed curly braces for me. And basically anything between these braces is what the method numerator entails. Now it's going to give back an integer, as we can see from here, and this method's purpose is to simply give back the numerator of the specific fraction that said person would be dealing with. So these are what we would call get methods. And those are comments if you don't know. They don't compile or they don't execute any code. It's just a comment for yourself for reference. And so what I'm going to do here is just return numerator. If you're wondering if having these named the same will cause any problems, the answer is no, because the way that we will call and execute this method isn't simply just by typing numerator. It involves a little bit more than that, and a couple of brackets and things. So it won't confuse the two. When I say return numerator, it automatically knows that I'm talking about the numerator in the instance variables. Okay, so I'm going to do the same for a denominator. Return denominator. And it has that nice autocomplete feature. So I'm going to group these accordingly. These will be called set methods. And for this one, and it'll be the same for denominator, the purpose of this method, if we think about it, is to take this integer that we're passing in. You'll hear that term. We're passing this integer in. And set it equal to, or set this variable, numerator, equal to this passed variable. So that's all we really have to do. Numerator is equal to n. End it with a semicolon, just like you would a period in English, and you're done. So we'll do the same for denominator. Equals d. And the purpose of this method will be to print out the fraction. Alright, so we'll put the curly braces, and what we'll do is I'll type it and then explain it, because it'll be easier for you if you just see it first. Printf, the fraction is %i / %i, and numerator, denominator. Okay, so what this is doing is, if you notice, if you go back to the header file, it inherits from the NSObject class, and inheritance is very simply put, it's just like inheritance of genes from parents. You know, you get certain methods to use and things like that. And so printf is a method that is inherent to all objects, and fraction is an object. So we're able to just use this printf message. You know, it works straight out of the box. You don't have to write anything. So it works straight out of the box, quote unquote. But anyways, the arguments that we're passing in is this string. Okay, we're passing in these quotations, and so we're saying the fraction is colon, and then these %i symbols are what probably caught your eye as quirky. Well, percent, as well as a couple other symbols, indicate that there's an object to be put here. In some other languages, you may have seen where it was a comment, something like the fraction is colon, end the quotation, plus, and then put numerator, and then plus, and then the slash, and then, oops, plus, and then the slash, and then plus, denominator. So we're concatenating all of these items into one string to be output. Well, the difference here is that this %i stands for an integer, and so does this one. So the first %i to occur left to right is the first listed integer to be placed there. So the first listed integer in the following arguments numerator will be placed right here.